Hello, I'm Hedley Appley, and in this session we'll take a look at the new features of Integrity Modeler 8.4. This will include open services for lifecycle collaboration, URL linking and tracing, extension to our ThingWorks trace management app, modeling simplification, large task scheduling and execution, and some other new features. So let's start with Open Services for Lifecycle Collaboration, OSLC. OSLC is a set of connectivity standards defined by the OASIS standards body. OSLC allows you to much more easily connect and integrate disparate tools to enable an end-to-end process covering the entire product development lifecycle. The key principles for OSLC are firstly a focus on the interaction between systems of record and not the internal behaviour of each individual system. This means providing loosely coupled integrations so that data is linked and not synchronized or replicated. With that in mind, OSLC systems can have resource providers and/or resource consumers. And Integrity Modeler 8.4 provides both. So let's start by taking a look at Integrity Modeler 8.4's OSLC consumer. We've extended the user interface to consume from OSLC compliant systems of record, allowing you to view remote resources and then create either local links to those remote resources or surrogates so that you can represent them on diagrams in Integrity Modeler. This gives you full life cycle traceability, allowing you to check the impact of change before making any design improvements, and then giving you a link not sync approach. So let's take a look at this in action. In this example, we use a simple electric car, and we start off by modelling the context. This has our car in the centre with the stakeholders and other systems that interact with our system around the outside. This gives us a great starting point for requirements engineering because it helps us identify all the stakeholders and all the interacting systems and constraints on our system. So once we've modelled the context, we can then move over to our requirements engineering tool of choice. In this example, this is Doors NextGen, and we can create new requirements, modify, delete requirements, all in that specific requirements tools database. And then once we're happy with the requirements, we can then use them in our systems model to help direct and define our system design. So now that we have some basic requirements in our requirements engineering system, let's move back into Integrity Modeler. Now we'll create a new requirements diagram, which at this stage is empty. And then click on the new tab in Integrity Modeler to show us all of our remote OSLC services. In this example, we can see Doors NextGen, Doors Classic, and Integrity Modeler, which we'll come back to later. And from the view on the left, we can drag those requirements in this example directly onto the diagrams and create surrogate items that represent those remote requirements. So this is a very small pointer in the model out to those remote resources that just allows you to represent them on diagrams. And from here on, we can then use Integrity Modeler as normal, adding local things into the local model database and linking them up maybe to those remote items, the OSLC links out to our remote databases. So there we've created a link directly from a local model item to a surrogate of a remote model item without synchronizing any data. We can also work by defining items in local models, such as this requirement, or even placeholders that we know we'll replace later. and then use the remote items and drag them onto those placeholders or existing items and convert them from local model items to surrogates, which point again out to the remote OSLC resources. As well as using those requirements on a requirements diagram, we can use them on any other diagram that supports requirements. And again, requirements are only an example. This could be any OSLC remote resource. And now that we've used this requirement on a use case diagram, in this example we can link it up and give it a trace link to refine a use case. So these remote links, OSLC links, act as any normal model item, and you have full linking and traceability across the whole chain. As well as using remote items as the same type, we can also map. So in this case, we've recognized that a doors requirement in this example is actually a use case, so we've used it as a use case in the model. Alternatively, if we don't need to show the items on the diagrams, we can create direct links from any model item out to any OSLC resource. You can define your set of link types and that direction, if you remember the upstream and downstream items we talked about earlier. And now that we've created some example links, we can see that in the property page we have a new tab. And in this case, this surrogate link for OSLC has a delegated web user interface provided by the remote system, in this case Doors NextGen, that we can see in the tab pane or in the main diagram pane, depending on the size of that delegated web user interface. And that gives us live access to the data in the remote system. And the same is true for linked items that aren't used as surrogates, so direct links from model items to remote OSLC resources. And we can also find the links and see the delegated web user interface for the information that's stored in the remote system. So once again, linking and not syncing the data. We can then use all of the normal tracing and linking facilities inside Integrity Modeler, so we can find out which parts of the system design implement which remote requirements in this example, and the other way around, look from a requirement and find out all of the things that are linked. We can also use the Relationships tab and navigate down through, in this example, requirements. We can see here are surrogate requirements from OSLC, see the use cases that implement them, and then even drill right down and see the reverse and go back up to the requirements that are local or remote. So that's the Integrity Modeler OSLC consumer, a generic consumer for any remote OSLC systems of record. So, as we've just seen, the Integrity Modeler OSLC consumer lets you browse remote OSLC resources from right inside the Integrity Modeler user interface. And then from that palette of OSLC resources, you can drag and drop them onto diagrams. This is then linking them and not copying or duplicating the data in the Integrity Modeler database. By dragging and dropping, you can either create links to model items, so that's just direct links, or surrogates, so things you can actually use on diagrams inside Integrity Modeler. And once you've got those links or surrogates, you can then see the item properties in the normal Integrity Modeler property pages, plus the delegated web user interface that's provided by the remote system of record. Then on top of that, all the normal traceability, impact analysis, and relationship navigation is available in Integrity Modeler. As well as the OSLC consumer, Integrity Modeler 8.4 also provides two OSLC providers. So let's take a quick look at both of those. We'll start off at the Integrity Modeler web user interface. And the OSLC providers are both self-documented using REST. So if we go to the OSLC extension of the web interface, you can see the information about the providers. Now normal users of Integrity Modeler wouldn't need to see this information. This is useful for developers building integrations just like the consumer we saw from other tools to access Integrity Modeler. But what it does show is that Integrity Modeler is providing two OSLC APIs. One for the requirements inside systems models, and one from all of the models, so the architecture inside systems models. So that data can be accessed from other remote systems, just like we saw Integrity Modeler consuming from Doors NextGen. So I know this is technical detail that most users won't see, but we just wanted to show you that we're making available the requirements specification and the architecture specification providers for OSLC. So that gives us two providers, one for requirements, one for model, which is OSLC 2 compliant, that can be used by other consumers of OSLC. So Integrity Modeler 8.4 can be plug and play, placed in a tool chain where OSLC is the connection mechanism to give other tools access to all of the information in Integrity Modeler, the SysML, the UML, and all the other information. So OSLC is a great standards-based approach for connecting tools in a tool chain, but not every tool supports OSLC. So now let's take a look at URL trace linking. Integrity Modeler 8.4 URL trace links can be very useful. They can link from any model item or diagram to any web resource. So this is similar to the OSLC types of links we saw a moment ago, but for non-OSLC tools. The links could be anything, so referencing websites, standards documents, specifications, wiki pages, maybe support cases in your customer relationship system, bill of material parts, in fact anything you can reference with a URL. This can include Integrity Lifecycle Manager and PTC's WINDCHILL. And once you use them in a model, you can also then navigate to those URLs. And we can use them both as links, like we saw for OSLC, and also as surrogates, so you can actually use them on diagrams. So let's take a look at this in action. So in this example, we're going back to the electric car, and we're going to create a URL trace link. We'll focus in on the wheel, and we have a logical wheel in the model, and here's our physical wheel defined in Creo and documented here in WINDCHILL. So we want to create a link from our logical wheel in our systems model out to that physical wheel in our PLM system. We can give the link a name, and in this case, rather than dragging and dropping from OSLC, we can simply paste in the URL that we got from WINDCHILL. We can give the link a type and decide whether it's upstream or downstream. And you'll see at the bottom that we get a preview of the web page for that URL. So now that we've created the trace, you'll see that we have a trace link in our items list, and we can see the properties of that trace link, and clicking on the URL tab like before, we can now actually see the web page for that part in WINDCHILL, both in the properties page and in the full diagram view. And in the diagram view, this is a fully active web page, so here we can view the data, and if we have the right privileges, edit it and make changes. This is really useful, particularly if we're maybe looking at requirements in Integrity Lifecycle Manager. We could use that to help define our design. Or here we can ensure that this part is satisfying our system level design. So just like OSLC links, now for the wheel we can see the HTML links, and here's our link out to the physical design for the wheel in WINDCHILL. So that was a direct link from a model item out to a URL. In other situations, we want to actually use that link on a diagram, so create a surrogate representation. So in a similar way to what we did with OSLC, I can create a placeholder block for the physical wheel, and then make this the link out to our URL. So create an HTML link. Again, I'll give it a name and paste in the URL. and this time I'll convert the link to a surrogate. So now we have a local representation, a very lightweight pointer out to that remote item that I can use as any normal modelling item. So in this example, I can create a trace link from our physical wheel to our logical wheel to show that the physical is the functionality is allocated from the logical to the physical. And now that surrogate can be used to browse the information both in the properties page at the bottom or in the main diagram page, and again this is a fully editable web page right inside Integrity Modeler. So the modelling user doesn't need to leave their environment to get access to that remote information. As well as seeing it locally inside Modeler, we can also jump straight to a web browser and log in and see that item directly in the host tool, so in this case in WINDCHILL. So we have tracing and linking, not just for OSLC type links, but tools that don't support OSLC using direct URL linking. So that gives us the ability to connect really almost any tool chain using a mixture of OSLC and or URL based links. We can use drag and drop for OSLC with that palette and use those on diagrams as links or surrogates. Or using copy and paste for URLs, and again we can use those as links or surrogates. This is a simple view with requirements linking to systems models, then linking onto PLM. Clearly this could be as complex as you need it to be, so linking out to support cases in your CRM system or multiple different connections in a whole tool chain with things like test and validation. So together, these facilities allow you to really use your systems model as a trace hub, the focal point for connecting with a functional design, connecting the worlds of requirements, logical design and physical design. As well as these new OSLC and URL based linking approaches, we've also improved our Navigate Manage Traces app, which has been renamed to ThingWorx Trace Management, Systems Engineering, Product Engineering. We've made it much more flexible, so now you can map from WINDCHILL parts to any item in Integrity Modeler. You can define those mappings yourselves, so it's specific to your organization. Once mapped, you can then decide what's shown in the ThingWorx Trace Management display. So you have available in this example use cases, actors and blocks, and you can also define the types of trace links available for the pull down at the top right. So when you use those new links, then they're displayed with the correct icons inside WINDCHILL in the Traces tab, also with the trace types shown in the column on the right hand side. So we've really extended this to be much more flexible, so you could link from, say, physical parts to system model functions, system model requirements, system model use cases, and not just system level blocks. SysML and UML are very powerful modeling languages, but the downside is that they can be quite complex, and this could make using Integrity Modeler quite challenging. So what we provided in Integrity Modeler 8.3 was the ability to use user roles to simplify the menus, the contents in Integrity Modeler. What we've done with Integrity Modeler 8.4 is extend that to provide lots of predefined user roles out of the box, and also some great starting points for creating your own user roles. And then these can hide things like toolbars, toolbar buttons, menus, menu contents, and browser contents. So let's take a look at these new user roles. We'll start off by looking at Integrity Modeler out of the box with all of the menus and toolbars available. So here we can see for a typical diagram that we have lots of browser panes, we have lots of buttons on our toolbars, many menu options available. So this is the full power of Integrity Modeler, and in this case SysML. However, not everybody needs to see all of this detail, especially if you're a new user or new to SysML, or maybe an infrequent user, or even focused on a specific role and you're only interested in maybe requirements or functional modeling. So in the user role selector, we now have a real range of available roles, everything from requirements authors to intermediate and beginner systems engineers through to IoT systems engineers. And it's a very simple case of just choosing the role that you want to take on when you're using the tool. So now we're a requirements author. We can see that the toolbars are much simplified. So we only have the things that we need for requirements in the toolbar, and we have many fewer tabs down at the bottom there, and the menus are simplified as well. And even the contents in the browser is restricted to, in this case, just requirements-based information. So much simpler, role-specific, giving you just the things you need without the complication of all the extra things available in the modeling language and in the tool itself. At any stage you can change your role, so it's not fixed, and here we can now kind of migrate from being a requirements engineer to a systems engineer and see a different type of information in the same model, and with other users with using different views to view the model in different ways. So it really helps simplify both the modeling languages of SysML and UML, and plus the user interface of Integrity Modeler. It needs all that power and strength to be a complete systems engineering and software engineering tool, but we could hide some of that to make it easier for you when you're using the tool in a specific role. Integrity Modeler 8.4 also improves large task scheduling and execution. We've provided a new Integrity Modeler model manager for executing and scheduling those tasks. It gives you easy access to do things like profile upgrades, creating new versions, exporting, importing, deleting, etc. We can also see pending tasks, running tasks, and completed tasks. And for the completed tasks, we can then do things like download the files. So let's see it in action. We start off with the dashboard. This shows us the completed, scheduled and running tasks and all the capabilities available. We log in securely with normal Integrity Model security. And here on the left we can browse into our servers and models and their versions. We can also bookmark them for easy access if we're administrating particular models more than others. So we'll take a look at an example model in our models repository. When we've chosen our model, in this case a model version, we can then see the available actions that could be taken. We can schedule tasks and then choose what action we want to take: deleting, exporting, importing, protecting, sandboxing, unprotecting, upgrading profiles and versioning. We can set a time and maybe even make it repeat. So this could be out of hours, maybe every weekend, for example. And there you can see the scheduled items, and you can stop them if you don't want them to run again. We can also execute tasks immediately, and the difference here compared to previous versions of Integrity Modeler is that it will run these tasks on the server. So this gives you dramatic performance improvements because it's not copying the data down to your client PC to execute the particular action. So let's run a model export. We'll run it now rather than scheduling. You can see it running in that middle pane, and it's now running in the background. So we can move to other tasks. In this case we'll go to a different model. In this case we'll upgrade the filling station model to the latest version. You can see that the completed tasks are shown at the bottom with their status, their results, and for exports you can see that there's an option to actually download the file. From here we can also jump to the Integrity Modeler web user interface to go straight and see the model. And all of its diagrams and information. And now our task is complete. We can filter the views. If we have a large number of completed tasks, for example, we can see those that completed successfully and those that have failed, and we can log in and log out. So a brand new user interface for executing those large tasks, giving us much more performance by executing them on the server. So we'll just finish off this session with the last few additional enhancements. We provided product line engineering with OVM, orthogonal variability modeling, in Integrity Modeler 8.2 and 8.3. One restriction was that we only had one level of sandboxing. So when you move from a product family model to a product instance model, that was created in a sandbox. But then if you created another product instance model, then that would be in the same chain of sandboxes. In Integrity Modeler 8.4, we've extended the sandboxing, so you can have any level of depth to the sandboxes. This now means that when you create a 150% model and maybe resolve that into a partially resolved 130% model, that goes into one level of sandboxing, and then you can resolve that further by making more decisions to maybe 120% or 100% product instance models, which then go to the next level down of sandboxing. This gives you much more control and visibility of the product family models and the product instance models with all their versions, so you can clearly see what's being created and run your trade study analysis on the correct lower level product models. We've also provided a facility for large package deletion, which really optimizes performance. So when you've got large models that have grown over time and you need to clear out whole areas. So we've looked at the Integrity Modeler 8.4 open services for lifecycle collaboration, both with the generic consumer dragging and dropping onto diagrams for surrogates and links, and also the two providers for requirements and models, so that you can use Integrity Modeler in an OSLC toolchain. We also looked at URL linking and tracing for tools that don't support OSLC to give you that direct connection. We then looked at the improvements to ThingWorx trace management to link to any model item type. We looked at modeling simplification to really hide the complexity of the standards modeling languages like SysML and UML, and also some of the complexity that can be there from the power of Integrity Model. We also looked at scheduling and execution of large tasks with the new model manager that run those tasks on the server to increase performance and give you better visibility. And the new features around sandboxing for system product lines and package deletion. These new features really make Integrity Modeler 8.4 stand out. It can now act as the systems model trace hub, both with OSLC and URLs, and the more flexible trace links with ThingWorx. The predefined user roles really improve simplification and help increase your productivity. And the large task scheduling and execution really improve performance and simplify model management. And we believe that these innovative and powerful new features are a significant advance over previous Integrity Modeler releases, responding directly to Integrity Modeler user needs, and once again leading the market.